Okay, good afternoon, all of you. So in yesterday's lecture, we have discussed about the Fourier's law of heat conduction. So can anyone tell me what is meant by Fourier's law of heat conduction? Anyone? Q is directly proportional to what? Area. Area which is normal to the direction of heat flow. And what? And change in temperature with respect to distance. What is the another name for this? dt by dx? Temperature gradient. So all of you remember this thing. dt by dx is nothing but temperature gradient. Okay. So this is the Fourier's law of conduction. This law is related to the conduction. Okay. So Q is directly proportional to area and change in temperature with respect to distance. So from that we get the equation as a Q is equal to minus K into A into dt by dx. So why the negative sign is there? Because whatever the dt is there, that temperature difference is nothing but small value minus bigger value. So therefore we have taken the negative sign. dt म्हणजे काय असणार आहे? What is the meaning of dt? Final temperature minus initial temperature. So final temperature always less than the initial temperature. So whatever the difference is there, that difference is in the negative. So we have to convert that value into positive. So for that we have to take the negative sign. Okay. So what is the meaning of this negative sign? So whenever the thickness will be increases, then temperature will be decreases. Okay. So that's why the negative sign is there. Okay. So for this solving the problems, whenever we have to taking the equation, at that time we have to take the equation as a Q is equal to minus K into A into dt by dx. If you are taking the negative sign, at that time what we have to take the dt? It is a negative sign घेतलं तर dt म्हणजे काय असणार आहे? What is the meaning of dt? काय असणार? T2 minus T1. And if you have taken the positive sign, so at that time what is the value of dt? T1 minus T2. Okay. So this is about the Fourier's law of heat conduction. After that, we have discussed about the assumptions for that Fourier's law of heat conduction. So what cases we have derived that derivation or we derive that equation. So for that, we have considered some assumptions. So what are that assumptions? We have considered as a conduction of heat takes place under steady state conditions. What is the meaning of steady state condition? Temperature does not changes with respect to time. Means whatever the phases are there. So this is the first phase and this is the second phase. Okay. So suppose at this time, this temperature is 100 degrees Celsius, and after 1 hour, if we are measuring this temperature, then also it is 100 degrees Celsius. Means temperature is does not changes with respect to time. That is nothing but steady state. Okay. So for the deriving the derivation, we have considered as a heat takes place under steady state condition. Okay. Then we have considered the heat flow is unidirectional. Okay. So whatever the all of you wait for 2 minutes. Okay, so what is the first assumption? Heat takes place under steady state condition. Steady state condition समजले का बघा सगळ्यांना. जी काही फेस असणार आहे, वॉट एव्हर दी फेस इज देअर, या फेसचं जे काही T1 टेम्परेचर असणार आहे ते काय असणार आहे, कॉन्स्टंट असणार. ओके, पण ऍक्च्युअल सिस्टम मध्ये तसं असणार आहे का, ते टेम्परेचर चेंज होणार आहे. ओके, सो दॅट्स वाय वी हॅव कन्सिडर्ड द assumption as a conduction of heat takes place under steady state condition. Okay, then the heat flow is unidirectional. ओके, आपण काय केलं, कन्सिडर केलेला आहे, जो काही हीट फ्लो होणार आहे तो एकाच डायरेक्शनला होणार. But in actual condition, what will happen? The heat transfer is takes place in all direction. It may be X, it may be Y, it may be Z. Okay, so for this derivation, whatever the equation we got, Q is equal to K into dt by dx. So for that equation, we have considered as a the heat flow is a unidirectional. Okay, then the temperature gradient is constant and the temperature profile is linear. जे काही टेम्परेचर प्रोफाइल असणार आहे ते कसं असणार आहे, लिनियर असणार आहे. मीन्स व्हॉट एव्हर दी व्हॅल्यू dt by dx we got, that value should be constant. This is the third assumption we have considered. Then there is a no internal heat generation. So whatever the component we have selected, okay, so this is the plate. तर ह्या प्लेट मध्ये आपण काय म्हणतो, इकडून हीट ट्रान्सफर केली ती इकडून बाहेर जाणार आहे, पण ह्या कंपोनेंट मध्ये पण काहीतरी हीट काय होत असते, जनरेट होत असते. Okay, so that heat also we have not considered. So therefore there is a no internal heat generation. Okay, then the bounding surfaces are isothermal in character. Okay, suppose this is a one plate, we have attaching the another plate to this plate. So whatever the interface between these two plates are there, whatever the temperature in between that two plate is there, we have to consider that isothermal, means constant temperature is there. Okay, so this is the one another assumption. Then the material is homogeneous and isotropic. So what is the meaning of that? The thermal conductivity is constant in all directions. So whatever the material we have considered having thermal conductivity is constant. So that's why we have taken the K as a thermal conductivity of this plate. Okay, so these are the assumptions. म्हणजे ह्या assumption वरून आपल्याला हे इक्वेशन मिळालेलं आहे. समजते का बघा, Q is equal to minus K into dt by dx. So for that we have considered these assumptions. Okay, so these are the assumptions for the Fourier's law of heat conduction. Okay, then after that we have discussed about the thermal conductivity. Okay, so what is the unit of thermal conductivity? Watt per meter degree Celsius or watt per meter Kelvin. तर ते कसं आलेलं इथे दिसतंय तुम्हाला, K is equal to what? What is the equation? K is equal to Q by A into dx by dt. Okay, so whatever the Fourier's law is there, we have rearranging the term K is equal to Q by A into dx by dt. Okay, so from that we get the unit of the thermal conductivity, that is watt per meter Kelvin or watt per meter degree Celsius. Okay, then from this, what is the definition of the thermal conductivity? Thermal conductivity is nothing but K is equal to Q. कधी असणार आहे, K is equal to Q when A is equal to 1 and this dt by dx is equal to 1. So in that manner we have defined the definition of the thermal conductivity, the amount of energy conducted through a body of unit area, okay, and unit thickness in unit time when the temperature difference between the phases causing heat flow is unit temperature difference. म्हणजे हा जो फॅक्टर असणार आहे dt by dx हा पण 1 असणार आहे. whatever the area is there, तो एरिया पण काय असणार आहे, युनिट एरिया असणार आहे. what is the meaning of unit area? 1 meter square. okay, what is the temperature? Unit temperature difference means temperature difference is 1. what is the thickness? That is unit thickness means 1 meter thickness is there. So whatever these properties are there or whatever these values are there, at that time we say that K is equal to Q. Okay, so after that we have discussed about the thermal conductivity of the solid, liquid and gases. Can anyone tell me which material having more thermal conductivity? Solid, liquid and gases. कशाची thermal conductivity जास्त असणार आहे? Solid ची जास्त असणार आहे. Okay, from alloys and metals कशाची जास्त असणार आहे? Metals ची जास्त असणार आहे. What is the reason for that? In metal, free electrons are there, maximum free electrons are there as compared to the alloys. Okay, then what is the effect of temperature on the thermal conductivity? If suppose we have to consider the solid, if you have to increase in the temperature of the solid, then what will happen? थर्मल कंडक्टिव्हिटी काय होणार आहे, डिक्रीज होणार आहे. व्हॉट इज द रिझन? Okay, so as we know that for the conduction major two factors are there. Why the conduction will happen? Because of the free electrons and lattice vibration. Okay, so whatever the heat transfer is takes place, from that 70% heat transfer is due to the free electrons and 30% heat transfer is due to the lattice vibration. Okay, so whenever we have to increasing the temperature means lattice vibration will be increases, and if lattice vibration is increases means that vibrations obstruct the flow of free electrons. Okay, so therefore what will happen? If temperature is increases, then thermal conductivity will be reduces for the solid. Okay, then what about the liquid? If temperature is increases, then what about the thermal conductivity? Decreases. Okay, what is the reason for that? Okay, if you have to increasing the temperature of liquid means what? Density will be reduces, and as we know that the density will be reduces means thermal conductivity automatically reduces. Okay, ज्या मटेरियलची डेन्सिटी जास्त असणार आहे त्याची थर्मल कंडक्टिव्हिटी जास्त असणार आहे, कारण सॉलिडची जास्त लिक्विड पेक्षा आणि लिक्विडची जास्त कशापेक्षा? गॅसेस पेक्षा, कारण सॉलिडची डेन्सिटी जी आहे ती जास्त आहे. ओके, इन दॅट वे फॉर द लिक्विड व्हेन वी हॅव टू इन्क्रीजिंग द टेम्परेचर द डेन्सिटी विल बी reduces, and as we know that if density will be reduces, thermal conductivity will be reduces. Okay, then what about the gases? If temperature is increases, then what is the effect on the thermal conductivity? Increases. So what is the reason for that? Okay, vibrational waves astar hai. Because of that vibrational waves, what will happen? For particular instant that molecules are coming to each other. Okay, so for that instant we have to consider the काय होणार आहे, तिथली थर्मल कंडक्टिव्हिटी इन्क्रीज होणार आहे, म्हणजे व्हायब्रेशन जे असणार आहे ते फास्ट असणार आहे, and because of that whatever the molecules are there, they are close to each other. Okay, so because of that heat transfer rate will be increases. Okay, so therefore for the gases what will happen? If temperature is increases, thermal conductivity will be increases. Okay, so all of you remember these things. Okay, after that we have discussed about the thermal resistance. Okay, so on what basis we have discussed this thermal resistance? Okay, so we have two systems, one is a electrical system and another one is a heat transfer system. Okay, so what is the law related to the electrical system? Ohm's law. So what is the equation of the Ohm's law? I is equal to dV by R. So what is the meaning of that equation? Current is flowing because of what? Difference in potential किंवा व्होल्टेज डिफरन्स. करंट जो फ्लो होणार आहे तो कशामुळे होणार आहे? प्रेस करून बघा. ओके, करंट इज फ्लोइंग बिकॉज ऑफ व्हॉट? पोटेन्शियल डिफरन्स. अँड विच फॅक्टर अपोजेस द करंट? रेजिस्टन्स. म्हणजे I इज इक्वल टू dV बाय R असं आपण म्हणतोय. म्हणजे करंट जो फ्लो होणार आहे कशामुळे पुन्हा फ्लो होणार आहे? बिकॉज ऑफ पोटेन्शियल डिफरन्स. अँड व्हॉट एव्हर द फॅक्टर विच इज ऍट द डिनॉमिनेटर, करंट वाढला म्हणजे रेजिस्टन्स जर वाढला तर करंट काय होतंय? कमी होते. म्हणजे रेजिस्टन्स काय करणार आहे? अपोजेस द करंट. ओके, इन दॅट वे वी हॅव द रिटर्न द इक्वेशन फॉर द हीट फ्लो. ओके, सो दिस इज द इक्वेशन फॉर द करंट. I is equal to what? Potential difference divided by electric resistance. Pramod. Okay, current is equal to potential difference divided by electric resistance. Okay, means current is flowing because of the potential difference, and whatever the factor which is at the denominator, that factor opposes the current. Okay, म्हणजे रेजिस्टन्स वाढला की करंट काय होणार आहे? कमी होणार आहे. Okay, in that manner we have written the equation for the heat flow. Okay, so heat is flowing because of what? heat कशामुळे फ्लो होत्या? टेम्परेचर डिफरन्स मुळे. जसं आपण इथं लिहिलेलं आहे, करंट कशामुळे फ्लो होते? करंट इज फ्लोइंग बिकॉज ऑफ द पोटेन्शियल डिफरन्स. इन दॅट मॅनर we have written the equation for the heat flow rate, that is Q is equal to temperature difference. म्हणजे टेम्परेचर डिफरन्स मुळे काय होणार आहे? हीट फ्लो होणार आहे. So we have taken at the numerator as a temperature difference, and whatever the factor is there we have to take at the denominator. म्हणजे आपलं इक्वेशन काय आहे? Q is equal to K into dt by dx. So we have to write down that equation in the manner of Q is equal to temperature difference divided by dx by K. हा K जो असणार आहे तो न्यूमरेटरला असणार आहे, तो आपण काय घेतलेला आहे? डिनॉमिनेटरला घेतलेला, म्हणजे आपलं इक्वेशन सेम आहे. ओके, सो नाउ दिस इज द electrical system and this is the heat transfer system. Now we have to comparing these two systems, and by comparing these two systems what we get? Current is analogous to what? Current is analogous to what? heat transfer. Okay, potential difference is analogous to what? Temperature difference. Okay, so from these two equation we easily understood that if electric resistance will opposes the current, then this factor will opposes the heat flow rate. Okay, म्हणजे हा जो फॅक्टर असणार आहे dx by k, this factor opposes the heat flow. म्हणजे हा काय झालेला आहे, हीट ट्रान्सफर सिस्टीम मध्ये हा रेजिस्टन्स झालेला आहे. हा फॅक्टर काय करणार आहे, तुमच्या हीट ट्रान्सफरला अपोज करणार आहे. ओके, सो फ्रॉम दॅट वी गेट दी थर्मल कंडक्शन रेजिस्टन्स ऍज ए dx by k. ओके, हा रेजिस्टन्स आहे तो कशाला एनालॉगस असणार आहे, इलेक्ट्रिकल रेजिस्टन्स इज एनालॉगस टू dx by k. ओके, सो फ्रॉम दॅट वी सेड दॅट थर्मल कंडक्शन रेजिस्टन्स इज इक्वल टू dx by k. समजले सगळ्यांना? दोन सिस्टीम आपण काय केलेत, फक्त कम्पेअर केलेत आणि त्याच्यावरून आपल्याला काय मिळालं, थर्मल कंडक्शन रेजिस्टन्स मिळालेला आहे, दॅट इज नथिंग बट dx by k. ओके, सो दिस इज द circuit diagram for that particular heat flow rate. Okay, so q amount of heat transfer will be takes place because of what the heat transfer is takes place, that is temperature difference, that is T1 and T2. So at that time what is the resistance, that denominator is nothing but resistance, that is dx by k. Okay, all of you get this point. इलेक्ट्रिकल सिस्टीम मध्ये हेच कसं असतं, इथं T1 आहे तिथं काय असतं V1, इथं काय असतं V2, इथं Q च्या जागेला काय असतं I आणि रेजिस्टन्स जागेला R असतं. ओके, सो वी हॅव कंपेअर्ड two systems. Okay, so this is about the thermal resistance. Then we have solved one problem related to the conduction, heat flow across the plane wall. We have used that general equation Q is equal to minus k into dt by dx, and we have find the value of temperature gradient, that is nothing but dt by dx. Okay, then after that we have law of convection. What is the law of convection? That is nothing but Newton's law of the cooling. Okay, conduction चा एकच लॉ आहे, that is Fourier's law of its conduction, and law of convection is nothing but Newton's law of the cooling. Okay, सगळ्यांना माहिती आहे का कंडक्शन, कन्व्हेक्शन, रेडिएशन? परत आता मी सांगत बसत नाही, माहिती आहे ना सगळ्यांना? सो व्हॉट अबाउट द कन्व्हेक्शन? कन्व्हेक्शन इज नथिंग बट व्हॉट? काय असणार आहे कन्व्हेक्शन म्हणजे? ट्रान्सफर ऑफ हीट ड्यू टू द मोशन ऑफ द मॉलिक्युल्स. ओके, मॉलिक्युल्स जे काय असणार आहे ते काय करणार आहेत, एनर्जी गेन करणार आहेत आणि त्या मोशन मुळे काय होणार आहे, हीट ट्रान्सफर होणार. दॅट इज नथिंग बट कन्व्हेक्शन. ओके, सो व्हॉट इज द न्यूटन्स लॉ ऑफ द कूलिंग? काय सांगा, व्हॉट इज द न्यूटन्स लॉ ऑफ द कूलिंग? रेट ऑफ हीट ट्रान्सफर पर युनिट एरिया. रेट ऑफ हीट ट्रान्सफर पर युनिट एरिया इज डायरेक्टली प्रोपोर्शनल टू व्हॉट? काय काय असणार आहे, टेम्परेचर डिफरन्स. म्हणजे जी काय बॉडी असणार आहे, जे काही सराउंडिंग असणार आहे त्याच्यामधला जो काही टेम्परेचर डिफरन्स असणार आहे त्याला प्रोपोर्शनल असणार आहे. ओके, मीन्स वी हॅव कन्सिडर्ड वन प्लेट and the temperature of that particular plate is Ts, and whatever the fluid is flowing on that plate having temperature is Ta. Okay, so at that time rate of heat transfer per unit area means Q by A is directly proportional to the temperature difference between body and its surrounding. Okay, what is the temperature kya hai? What is the temperature of body? Ts, and what is the temperature of surrounding means whatever the fluid is flowing on that particular plate, that is nothing but Ta. So Q by A is directly proportional to Ts minus Ta. Okay, so for the proportionality constant kya asnar hai? What is the proportionality constant for the convection? That is nothing but H. H is nothing but convective heat transfer coefficient. So from that we get the equation as a Q is equal to what? Q is equal to H into A into Ts minus Ta. Okay, so this is the final equation of the convection. Whatever the heat transfer is takes place due to the convection. म्हणजे ज्या वेळेला कन्व्हेक्शन मुळे हीट लॉस होणार आहे त्यावेळेला जर तुम्हाला रेट ऑफ हीट ट्रान्सफर फाइंड आउट करायचं असेल, at that time you have to use this equation. Q is equal to H into A into Ts minus Ta, and whenever the heat transfer is takes place due to the conduction, at that time we have to use Q is equal to K into A into dt by dx. एखादा प्रॉब्लेम असेल त्यामध्ये कंडक्शन पण असणार आहे, त्यामध्ये कन्व्हेक्शन पण असणार आहे. सो ऍट दॅट टाइम वी हॅव टू सी विच मोड ऑफ हीट ट्रान्सफर इज देअर, वेदर कंडक्शन इज देअर, वेदर कन्व्हेक्शन इज देअर, अँड अकॉर्डिंग टू दॅट वी हॅव टू यूज द इक्वेशन. ओके, कंडक्शन असेल तर K into dt by dx घ्यायचं, कन्व्हेक्शन असेल तर HA into Ts minus Ta घ्यायचं. ओके, so what is the equation of the convection? Q is equal to H into A into Ts minus Ta. So from this equation can anyone tell me what is the thermal convection resistance. What is the formula for that? 1 upon H into A. Okay. So whatever the temperature difference is there, we have to take at the numerator. Okay. And what is the value at the denominator? 1 upon HA. So whatever the denominator is there, that is nothing but resistance, and that resistance for the convection. So therefore, we said that that resistance is nothing but thermal convection resistance. आता आपण जो बघितलेला काय होता dx by k हा कशासाठी होता thermal conduction resistance. Similarly, we have written the equation for the thermal convection resistance, and what is the equation for that? 1 by HA. समजले सगळ्यांना? जरा चेक करा. Okay, and what is the unit of H? Can anyone tell me what is the unit of H? Watt per meter square degree Celsius. आणि thermal conductivity काय आहे? Watt per meter degree Celsius. Okay, एवढाच डिफरन्स आहे की इथे मीटर स्क्वेअर आहे आणि थर्मल कंडक्टिव्हिटी मध्ये काय होतं? वॅट पर मीटर डिग्री सेल्सिअस. ओके, तर हे बघा Q is equal to H into A into TS minus TA. So we have written this equation as a temperature difference divided by remaining factor. So what is that remaining factor? 1 by HA. So that 1 by HA is nothing but thermal convection resistance. Okay. So now we have to write down one problem. Write down, all of you write down. A hot plate. Write down a hot plate. A hot plate. एक मिनट थांबा, सिंपल आहे जरा. हा प्रॉब्लेम घ्या सर. Write down a wire 1.5 mm in diameter. A wire 1.5 mm in diameter. 1.5 mm in diameter and 150 mm long. And 150 mm long is submerged in water. Is submerged in water at atmospheric pressure. A wire 1.5 mm in diameter and 150 mm long is submerged in water at atmospheric pressure. At atmospheric pressure. At atmospheric pressure. Full stop. An electric current is passed through. An electric current is passed through. An electric current is passed through the wire. Passed through the wire and is increased until the water boils. And is increased until the water boils at 100 degrees Celsius. Increased until the water boils at 100 degrees Celsius. 100 degrees Celsius. Full stop. Under the condition if convective heat transfer coefficient. Under the condition if convective heat transfer coefficient is. If convective heat transfer coefficient is 4500 watt per meter square degree Celsius. 4500 watt per meter square degree Celsius. Watt per meter square degree Celsius. Find how much electric power must be supplied. Find how much electric power must be supplied. Electric power must be supplied to the wire. Must be supplied to the wire to maintain the wire surface. Must be supplied to the wire to maintain the wire surface at 120 degrees Celsius. 120 degrees Celsius. Okay, so all of you read that problem carefully. First of all, write down the given things. Okay, so whatever the given in the problem, that we have to write down. A wire 1.5 mm in diameter, means diameter is given. So write down D is equal to 1.5 mm. So we have to convert that mm into meter. Okay, so 1.5 into 10 raised to minus 3, that is meter. That is meter. Okay, then and 150 mm long is submerged in water, means length of the wire is given. L is equal to 150 mm. L is equal to 150 mm. So we have to convert that 150 mm into meter. So that is 0.15 meter. Okay. Then an electric current is passed through the wire and is increased until the water boils at 100 degrees Celsius. ओके, म्हणजे हे वॉटरचं टेम्परेचर असणार आहे. वॉटर बॉईल व्हायचं टेम्परेचर 100 डिग्री सेल्सिअस आहे. म्हणजे हे TF असणार आहे फायनल टेम्परेचर. आणि इनिशियल टेम्परेचर जे आहे ते आपल्याला दिलेलं आहे. सरफेस टेम्परेचर, वायर सरफेस टेम्परेचर, दॅट इज 120 डिग्री सेल्सिअस. ओके, TS इज इक्वल टू 120 and TF is equal to 100 degree Celsius. Okay, so all of you, I will send one link to the group. First of all, we have to attend that lecture, then we have to continue our lecture. Okay, so I will share one link to the group, so all of you join that lecture.